So we found our angle alpha, right, which is this angle over here. So now we want to find our stress Y35 and shear Y35. Okay. So let me expand the view a bit. It's a bit messy over there. Okay, so we have our point over here is our point O. And then we have found that there's an angle of 19.8 degrees. Okay. So this is our angle, which is 19.8. On point 0, we know that the normal stress is 20, the shear stress is 0, right? So at this point is our Y35. And our Y35 has a normal stress, right? And a shear stress Y35. We know that the radius of that line is equal to 39.051. So it's very easy to find what is the normal stress and shear stress on Y35. So now let's start with the shear stress. I usually like to do the shear stress first. It's more straightforward. Okay. So we know that the shear stress Y35 is also equal to the shear stress X35, right? So this will be equal to sine, right? Or 39.051. 39 multiply by sine of 19.8. Okay. You don't need to add anything or minus anything because the shear is start from 0, right? So sine 19.8 times by 39.051 is equal to 13.22. Okay, 13.228 megapascal. Okay. Then now we go into the normal stress 35. Now, hold on, let me do it in a graph paper view. Okay, then let me shift this first. So we know that now we want to find stress Y35. And it's going to start from 20, right? Because at the center of the circle is normal stress 20, shear stress 0. So 20 is going to move towards its left-hand side, so it's minus, right? And then we're going to calculate 39.051. And because we have used sine already, we need to change it to cosine. Okay, 19.8. That's why I do sine first, okay? Then you know the next one, you have another factor to consider, which is the 20. So you know that it's cosine, okay? Then we'll maybe. So this is 20 minus by cos 19.8. That's by 39.051. It's 36.742. I do it again, cos 19.8 times by 39.051, 36.742. So 20 minus 36.742 is equal to minus 16.742. Okay, right? So that value over there, if we go back to the graph paper mode, right? Yeah, is like, yeah, it's more than probably my angle It's not really good. Let me calculate cos 19.8 times by 39.051. 20 minus my, yep, minus 16. Okay. So now we also know that the stress x35 is equal, so stress x35 is from the center of the circle move towards the right. So it's 20. And then you just plus by 36.742. Right. So this is equal to 20 plus 36.742 is equal to 56.742. Okay. So it's 56.742. I think I know why it looks off. My bad. It's not 20, it's 25. Because if you look at my mistake, okay, look at where the normal, where the this is 25. I put it at 20. That's why it looks off. That's why it don't look right at all. I do apologize. So this by right is 25. Okay, so 25 minus by 36.742 minus 11. Okay, minus 11.742. Now I think that's why it's important to draw accurately. Right now this look like normal stress minus 11. Just now when I did it, 20 was not. So this is 25. Okay, so 25 plus 61.742. Okay, so we now know the value, right? Next is to put it back into the element. Okay, now putting to draw everything back to the element, this one is more difficult than the one before because now you have shear. Okay, the one that we did earlier has no shear at all. Okay, so now we have to consider shear. So now we're going to construct the element. Okay, so we do the original first. So we do the original. So this is x, and this is y. Okay, so this is x, and this is y. And then we are going to rotate the element by 35 degrees clockwise. Okay, so 35 degrees axis clockwise. So now I'm sketching my 35 degrees now. Okay, so this is my 35 degrees. And then I'm just going to okay. So now I'm going to draw the element. And I'm going to draw element. Ah, silly me. It's okay. I'll just move this closer. Okay. So this is our element now. Okay, this is our element now. At 35 degrees orientation. Okay. This is our element now. So from here, I am now going to draw, right, a horizontal line. Wait, let me see, am I doing this right? 35. Yep. Okay. So we draw our horizontal line. here. And we draw our vertical line here. So this we know was our point Y. This over here is our point X, right? So Y, so we know that this is 35 degrees, right? And then it's 70 over here, right? So we know that Y35, normal stress Y35 is in compression. So the normal stress is easy. Okay, the normal stress, you all should know how to draw this now. So this is 11.742. And then on the other side, right, X, right, clockwise 35 is 61.742. 61.742. So the normal stress is easy. Now, we have to look at the shear. Okay. Let's focus on Y. So this is our Y35, right? This is our X35. Okay. Now, if you look at the Y35, the element has to rotate what? Okay, where I'm circling now, the element has to rotate clockwise, right? So on Y35, for the element to rotate clockwise, it has to be pushing down in this direction, right? Then it will generate a clockwise rotation. And that value over there is 13.228. I'm going to use a different color now. I'm going to use red, right? And if you look at X35, which is sitting in red now, the element rotation is anti-clockwise. For element on X35 to rotate anti-clockwise, the shear has to be in this direction. Then it will rotate what? In this anti-clockwise direction. So this is the only thing that's difficult or more than what the example that is before. Okay, so this is the stress state at the element rotate 35 degrees clockwise, right, from the horizontal. Now, what if, right? What if you want to start from surface X? To start from surface X, this angle is no more 35. This angle is now what? So 90 minus 35 is 55 degrees, right? So if you start from point X to do 55 degrees, anti-clockwise, your answer has to be the same, okay? So now, if I go back to the Mohr circle, now we are going to start from point what? X. Point X 55 degrees, right? On Mohr circle is what? 110. So this rotation, look at the rotation is in what? It's in a counterclockwise rotation at 110 degrees. We end up in the same point, right? 110 degrees, right? We end up in the same point or same plane, right? So over here is on Mohr circle is in anti-clockwise direction. 55 degrees also in what? Anti-clockwise direction. Are we clear? Okay. So be comfortable. You want to take from point X, point Y, the answer will always be the same. Okay. So this is the most important thing about Mohr circle. You need to be able to draw from element to Mohr circle and bring it back to element with the associated stresses. Okay. Now, so this is 2D Mohr circle. Now, 3D Mohr circle is not more difficult than 2D Mohr circle. Okay. This is still, if you ask me from 2D to 3D, how much more difficult? how much more you have to learn? Maybe not more than 20%. Okay, the bulk is the 2D Mohr circle, the fundamental foundation.